Hi everyone, this is our last lesson for Unit 4. We're going to get into lesson 4.9, which is position versus time graphs. And sometimes these are called motion graphs. So by the end of the video, I'd really like to be able to show you a motion graph and have you be able to understand how to analyze and interpret it. So let's get into what a motion graph is. So number one, a position time graph, or in other words, a motion graph, shows a relationship between your position as time goes by. So what does that mean? Well, let me give you an example. What if you were at home and you were going towards school? Let's say that right as you walked out the door, you took your cell phone and you started timing yourself. Now, as you walk, your time is always going to be moving forward. So in other words, your time numbers go up and up and up. Like you can't go backwards in time. Your cell phone is going to track your time. However, your position can vary. So your position can go either up or down. So that means that if you go away from your house, your starting point, and you go away from it, your position goes up. But if you're going to forget something at home and you go back towards your house, so you go backwards, that means your position went backwards and it can go down. So these two things, time and distance, are basically what you're going to see in your motion graphs. And those are your independent and dependent variables. So obviously your distance depends on how much time has gone by. So the distance that you are from your house depends on what time it is. Okay, so once you have those two variables, you can calculate your speed. So in order to calculate your speed, there's a formula right over here. You take your distance and you divide it by the time. So the distance, since it's your dependent variable, is actually your rise, your y-axis, and then the time, which is your independent variable, is on your x-axis. So when you take rise over run, you get your rate of change, and so speed is just a rate of change. Actually, you might have seen a couple of these on the road before. You know speed limits like 40 kilometers per hour? That's a rate of change because you have 40 kilometers, which is a distance, over 1 hour, which is a time. Okay, so that's actually how they calculate the speed. So let's see what an example might look like. This is called Rubina's walk to school. And let me explain it a little bit. So on the left-hand side, you see your distance. In other words, your position from home. So let's just say that anywhere along the bottom, this is basically where home is. Okay, and actually I'm just going to draw a little home right here. All right. Now, as you go up farther, you're getting farther and farther away from home. So the arrow stops at 2,000 meters from home because it looks like they're measuring in meters. Okay, now this is like if you set your timer and time goes on. So my arrow is stopping at 20 minutes. It's always good to kind of know what we're measuring our variables in. Okay, now in order to read this diagram, our motion graph, we also need to know, well, what about all those numbers in between that aren't shown? So you should know that this is number 1, there's the 2. 3 is here, 4, and then 5, and so on. So just because they don't write it doesn't mean that you don't know what's there. The same as the other side. So 0, this is 200, then 400, then 600, 800, 1,000, because it looks like it's going up by 200s. So again, just because they don't write those numbers, like you should know that that's what they mean. When you have the distance and the time and you divide them together, you can find the speed of each of these parts of her walk. Now, she's going to school. So where is the school? Well, if your home is anywhere down here, then you're walking towards your school that's somewhere up here. I know that's kind of weird. You're not actually walking this way. You're walking away from your house, but you're walking upwards towards the school. Now, if you forget something, like let's say you're walking away from your house and you forget something, you want to go back to your house, that's what going down means. It means you're going closer to your home, right? If you want to go closer to the school, you go towards the school. Now I'm just like doodling everywhere. Okay, so let's just say her school is somewhere near the top. You know what? I'm gonna draw a school right here with a little flag. Okay, so what we have to do now is we actually have to start answering some of the questions, and they want us to fill out this chart. So let me show you how they actually filled out the chart. The first section is section A. So section A is right here. And what's going to happen is we have to figure out what the distance is. Okay, so the distance for just section A is we're starting from this height, and then we're going to go to this height. Well, this height is 0, and this height, what is that number again? 600, that's right, so 600. So if we started at 0 and we went up to 600, that means we went 600 meters away from her house. And then we stopped, and then that's when B happens, but we'll talk about B later. Now we're going to talk about the time. So the time is over here, starting right there, and we're going to go all the way to this time. So we started at 0 and we went to the time of 6. So how much time was that passed by? 6 minutes. Now that you have your time and your distance, you're going to take your distance divided by the time to find the speed. So 600 divided by 6 is 100, and make sure, very, very important, that you have the correct units. So meters per minute, because it's meters divided by minute. All right? Now you just write a description about what's happening. So she started from home, and then she started traveling 600 meters in 6 minutes, and she traveled away from her house. And you can put in the speed too, so she traveled at 100 meters per minute. Okay, so let's take a look at part B now. So this is part B. What is the distance? Okay, so the distance is if you start from here, which was a distance of 600, and then you ended here, well, it didn't look like she went up at all. So she still stayed at 600. Well, that means that she didn't go any distance. If you started the clock and she was 600 meters from home, and then you ended the clock and she was still 600 meters from home, it means that she didn't move. But the time moved. The time went from 6 minutes all the way to 10 minutes. So that was 4 minutes that she just stood there. She was 600 meters from her house for about 4 minutes. So her speed was, well, nothing. She stopped. 0 divided by 4 is just 0 meters per minute. What we can say as a description is, well, Rubina stood still. That's a good way of saying she didn't go anywhere. She stood still at 600 meters away from her home. So she was 600 meters from her house for about 4 minutes. And why? You know what? She was talking to her friend. Okay, so let's take a look and see if we can do this ourselves now. Let's try C. So this is C, and let's talk about the distance first. So she started at this distance, which looks like it was about 600. Okay, and then she went all the way up to this height, which is about 1,000. So how much did she move upwards? Well, 1,000 minus 600 is about 400. So it looks like she went a distance of 400 away from her house. Now the time, you're going to take a look at this number. So that's when she started, and then she stopped at 14. So how much time was that? Well, that's 14 minus 10 is 4. So 4 minutes. I wrote that down over here, so here's my 4 minutes, and there's my 400 meters. Now when you divide them, you're going to get your speed. Remember, you're always taking your distance first, and then you're dividing it by your time. So 100 meters per minute. So I just wrote a little description, I made it up. She continued to travel away from her house for 400 meters for 4 minutes. And that was at a constant speed. So I said constant speed because it's just a straight line. She just kept going at 100 meters per minute. She didn't run. She just kept walking. Okay, so at a constant speed of 100 meters per minute. All right, let's try the next section, which is this little guy right here. Okay, so let's do the distance first. Now the distance for this part right here is 1,000. And even at the end, it was still 1,000 because they're at the same level, right? So if you started your timer and you ended your timer and at both times the distance was 1,000, well, that means she didn't move anywhere. But time did go by. How much time? Well, you started your timer at 14 and you ended your timer, what is this time? That's right, 15. So 14 to 15 is only 1 minute long. There you go, 1 minute. Divide them and then you're going to get your speed. And so 0 divided by 1 gives you 0 meters per minute, which means that she wasn't moving. 0 speed means she stopped. So I said she stopped for 1 minute, and I just said, you know, she had to tie her shoe. So for the very last part, right here, the distance is going to be, let's see, well, she started down here and she ended at the top. So let's see, started at the bottom. That's going to be about 1,000. And then the top up here, let's see, I think that's about 1,800. So how much did she actually go up? Well, if you subtract them, you're going to get 800, and that's going to be my distance. Okay, now let's figure out the time. So the time started at 15, and then it went until 20. So that's a difference of 5 minutes. And if I divide them, I'm going to get my speed, and it looks like I get 160 meters per minute, which is actually faster than she had been going before. So I said that, you know what, she ran. She realized that she was late, and she decided to run the rest of the way all the way to school. So that is our little, I guess, story. And so let me go through this with you one more time just so that you can kind of understand it. So at the very beginning, she's walking away from her house. When it's flat like this, it means she stopped. So notice that she stopped again over here, but she stopped for a longer time because she was talking to her friend. And this was because she was tying her shoes, so she didn't stop for very long. This looks the same slope or steepness as this one. So if they're the same steepness, she was going at the same speed, but this one is just slightly steeper. So that means that she ran, and the entire time she's going this direction towards the school. If she forgot something, she wouldn't actually go this way. If she forgot something at home, she would have gone this way, back towards her house, which is anywhere near the bottom. Okay, sorry that was kind of messy, but I hope you understand. So let's see if you do understand. I'd like you to try this for homework by yourself. We have a motion graph right here, so a position versus time graph. You might actually find it a little bit easier to try and fill out this table first and find all the speeds before you start answering some of the questions. But you can answer some of the questions first. It's up to you, however you want to do it. All right, so I hope you have a great day. This was our last lesson, and then we're going to move on to measurement and geometry. See you later.